All right, welcome back, everyone, to another edition of the Sourcegraph Podcast. So today, I'm going to do like a brief intro, like a scenario. So let's say you built your amazing next-generation web app of the future, and you have all the features in place, but you want to enable teams to use it. You now need to go and figure out how permissioning should work in your application, who can see what, who can allow others to see stuff, and all the messiness that involves. But privacy and access control are super important, especially if you plan to make money. Many of us have been there. I know I certainly have. It's messy. It's a headache. But thankfully, there's a new library that can help with that. So today I'm joined by Sam Scott. He's the creator of Oso, a batteries-included open source library for building authorization straight into your application. It's got a special purpose language for describing your authorization policy, complete with a debugger and REPL, and a set of APIs to easily bake this into your application. Prior to Oso, Sam was a PhD researcher in cryptography, so he knows what he's doing. Sam, thanks for joining us today.
Thank you very much for having me.
Awesome. So to kick things off, before you became this kind of expert in all things auth and security related, how did you get into computers in the first place? What was that kind of initial foray for you?
Yeah, I mean, my illustrious security career started when I was like 14 and deleted DOS because I was trying to make space to install more games. Yeah, I mean, I wasn't that like typical like security hacker person who like grew up coding. I actually was somewhat late to the game, I guess. It was I was doing an internship when I was going to college, and one of the jobs I had was like super tedious data entry in Excel. My Monday morning was like copy and pasting Excel formulas around and waiting 4 hours for the VLOOKUP to go through all the rows. And by nature, I'm super lazy. And I think this is a trait that many programmers have. By nature, I'm super lazy. And I was like, there must be a better way to do this. And I started learning about the world of VB macros in Excel. Quite a starting point for programming. But yeah, I was able to like automate my job away, basically.
Nice.
Luckily, they didn't just like fire me on the spot. They instead were like, hey, this is cool. And sort of nurtured it a little bit, introduced me to some of the actual engineers on the team who kind of took me under their wing from there. That's how it all began.
That's awesome. Okay, so this is like an internship that you did during your college years?
Yeah, that's right.
Okay, and then one thing led to another. You were math undergrad.
That's right.
Right?
Yeah.
Or okay, so did you come to your senses after graduating and decide to get into computer science or cryptography, or was this kind of like a slow transition?
Yeah, I mean, for me, it was. I kind of fell into maths. I mean, I enjoyed it. I sort of fell into it, but throughout my undergrad, I was sort of interested in like understanding what to do with maths and looking for more applied things to do with it. I'd say most mathematicians on my course were like talking to like banks and finance places. That was the typical path. It was kind of finance or teaching in the UK. That's kind of like the two of the main career paths.
Yeah.
But I randomly learned about cryptography because my granddad like had a book on it, and I just kind of like started leafing through it and was like, oh, this is super interesting. This is a kind of applied version of maths that can do some real like problems, and learn about like Enigma and Turing and all the way to like modern cryptography, things like RSA. So that's where it started. Awesome. It was like, oh, cryptography is applied maths. And then I started doing cryptography and continued to want to find more and more applied versions of it, which yeah.
Was your granddad involved in any sort of early cryptographic efforts, or was it just like a book that he had on the shelf out of personal interest?
Yeah.
Okay,
I mean, he was himself like mathematician, statistician, but he was just widely curious and interested in topics. So I think that's where it was.
Cool. So you got into crypto, which at the time stood for encryption and things like that, not for
yes, thank
cryptocurrencies.
You. Crypto, which I'm now conditioned saying cryptography unless someone mistakes me for. Lost that fight.
What was? Yeah, it's over. Yeah, it's. We'll see. But yeah, how was that? So you went from math into crypto, and you ended up doing a PhD in cryptography, right?
Yeah, that's right. Yeah, I mean that was a lot of fun. First, a lot of the cryptography from the math side of things was very like number theoretic. It's learning about different kinds of like abstract maths around different structures of numbers or elliptic curves and all this kind of stuff. And it was like very fascinating stuff, especially just seeing, how some of that could be directly applied to real life things. Like, one of the first paper I published on my PhD was like a deeply mathematical topic around, solving this bizarre variant of this Diffie-Hellman problem. It's like one of these core cryptographic primitives using a lot of things, very number theoretic. And the paper was like basically just pure mathematics. It was a different approach to solving this algorithm in faster time. But the implications of it was a real world attack on a protocol being proposed for EMV credit cards. It was like a suggested way that they could basically like blind and hide transactions so that you couldn't eavesdrop on transactions and see see where they came from. You couldn't say this card had made those two transactions if you just like listened to the traffic. But there was like a small assumption they made that like turned into this like very interesting like number theoretic problem. So that was like, I think that really, I was hooked at that point, that you could be solving those really like fun, hard problems, and the like implications of them are like very real.
Yeah, that's awesome. So did you end up doing your thesis on that, or
my thesis was a mess.
Something else?
My thesis was an absolute mess. Yeah,
I feel like that's not atypical from what I've heard from like PhD friends.
Yeah, well, I mean, I'm sure everyone remembers that thesis as fondly as I do. I mean, mine was a mess because I moved around a lot, and I didn't stay on one topic because I kept on. It was never enough. It was never applied enough. So I started out with the maths background. I enjoyed that, but I wanted to move out of the maths research into some of the more applied stuff. So that led to me working with like new set of professors, and working with some professors out of Cornell Tech. Like we did a research paper inspired by some like password security problem that Facebook had, and that kind of took me in a completely different direction. I did a research intern.
That sounds parser security.
Password,
so like defending against essentially like denial of service attacks, where you can make the parser go into infinite loop or something like that, or
like username and password.
Oh, passwords. Yeah. Okay, got it. Got it. Okay, cool.
Yeah, that was like a talk that Facebook gave at this conference called Real World Cryptography, and they basically shared this crazy password hashing onion thing they had, where it was like they had like layers of different code craft because of like how cryptography knowledge had progressed. That at first they used MD5, and then MD5 was broken, they used something else, and they had like all these layers. And yeah, later I did a like research internship at Mozilla, where I was working with one of the editors of the TLS 1.3 specification, did formal analysis of that. And so I ended up with this kind of mismatch of this random collection of research papers that had very little tying them together. And so I kind of gave it this umbrella term. What was it? The design and analysis of real world cryptographic protocols, which just meant like I did things. I looked at things and studied them. And it was a lot of fun, but it was definitely not like a cohesive research topic. I think it
sounds like you were, oh, sorry, go ahead.
I think it was interesting, from like the survey standpoint, like comparing techniques, but that's not exactly what research is supposed to be about.
Yeah. I mean, it sounds like you were pretty practically minded in terms of, how you chose all these different things. And perhaps, even at that point in the depths of your PhD, you were already anticipating a jump into industry or more applied stuff.
Yeah. The PhD itself was So the promise of the PhD was that it had a lot of interaction with industry. Like I sort of like, I wasn't fully committed to the idea of doing PhD purely for the research sake, and this one had like industry tie-ins. So like that one sort of hit that balance. I was like, okay, I can do a bit of both.
Yeah.
Yeah.
Cool. So did Oso kind of grow out of some of the work that you did
Not in the slightest.
in your academic studies? Well, what was the path from that to starting Oso?
So the path was, I ended up in New York. As anyone who's watching the streamed video of this version can see from my background, this is basically where I live right now.
Nice.
I ended up in New York because, as I said, I did some research papers with some people out here in the States. And they were keen for me to come out to New York and do a postdoc here. But at that point I was like, no, I want to go into industry. Like, academia is not for me. And they said, well, there's a like startup program here at Cornell Tech that will, allow you to basically, explore different topics around, different startup ideas, in collaboration with us here. So if you want to investigate some like research with us, like we can, potentially do that as a company idea, which just sounded like absolutely perfect to me. And I was like, that's the dream. That's what I want to be doing.
Cool.
The program itself, so it's called the Runway program at Cornell Tech. What they do very nicely is they, encourage you when you first start out to, explore your ideas a bit more, go out and talk to people, understand what problems they're facing. Basically very gently telling me in particular, like, your ideas are awesome, but you might want to like understand what, problems the world's facing. And that was me thinking I was doing very like super applied research. But the stuff I'd been researching just wasn't the kinds of things that like the real world were actually, outside of the Googles and the Facebooks of the world, like most of the world weren't grappling with these. So that was kind of like a rude awakening. And it was like, oh, I see like this, some of the problems that are out there in the real world are, in some ways considered solved by academia, but really aren't.
Yeah.
Yeah.
Is it this? So would you say that there are a lot of ideas that are mature in the academic setting that just there's been no vehicle to make them mainstream, or is there like a complexity in operationalizing some of these that has prevented their adoption?
Yeah, it's a bit of both, really. I think the last thing you say really hits on a lot of it, actually. A lot of cryptography, a lot of the really interesting research, in particular, a bunch of the research I did, assumes that you have, a secure way of like sharing secrets with each other. Indeed, that's like the cornerstone of lots of the stuff that everyone uses out there, from, passwords or certificates in TLS and, encryption, like all of them, a lot of them depend on that. And, but there's plenty of nuances around how you do that. And, as it turns out, secrets management is an entire industry, in the real world, because it's actually a hard problem to deal with. So it's not something you can take for granted and just say, well, like, assume we have that, then like we're going to go and solve these problems. It's like, well, I don't know, really rewind a bit. Like, and I think that's what you're referring to, right? When you say, the operationalization, it's, deploying these things. If it means some complex secrets management and a bunch of assumptions that you can't typically make, then, potentially it's a non-starter.
So from your perspective, there are just like these like table stakes sorts of things that most companies just don't have yet. So before we can get to all the advanced like algorithms and cryptographic mechanisms, we need to start with the basics. And one of those basics is just like authorization or permissions, or like what?
Yeah.
What's the term that you use? Because I hear a lot of things: authorization, authzy, permissions, ACLs.
It's a good question.
Access control.
I mean, honestly, we're experimenting with language a lot because, what we understand by a word isn't necessarily something that resonates with our audience, with developers, and we do go to great length to try and meet developers where they are. So, we try to not use acronyms like RBAC unless we think that's something that people are specifically looking for because someone said, hey, go build an RBAC system. They're like, what? So yeah, I mean, I think the thing we've built is, an authorization framework. And what you get from that is a way to build roles and permissions into your application, right? Like that's like, as an app dev, the product feature you get to ship is, roles and permissions and, securing access to data. An authorization framework would be the way you achieve that. Cool.
So just to take a step back here and like context set, when I think of like privacy and security from the application layer, there's maybe like two main areas that people talk about. One is authentication, or authn, which is how do you sign in? I think fundamentally that's solving like, who is this user? Like, who am I? And then there is authorization, or authzy, sometimes called access control, sometimes called permissions, which is more about like, once given I know the identity of the user, what are they allowed to access? Because in any given application, there's certain data that's sensitive, that's for, someone's eyes only and not for someone else's. And that becomes a whole, it can become messy because there's individual permissions. Those individuals are parts of teams. Teams are granted permissions. There might be like ad hoc permissions granted back and forth because you want to share data, but only if someone with the proper authority or authorization, has the permission to share that data with others. And it often becomes this very tricky problem. And it's like, when you're trying to build an application, you want to be focusing on like the feature set. And then this whole thing is like, I wish it were an afterthought, but it becomes deeply embedded into the logic of your application. And that oftentimes that's tricky. So, and you all are trying to solve that, make it like, more standardized, and easier to develop, because this is also a big source of bugs, I think, right? Like someone commits a bug and, all of a sudden, like someone who shouldn't have access can see sensitive data, and that's no good.
Yeah, exactly. It can either go, that path where you end up with, data breaches, data exposure, or you go the other direction and maybe the controls are super, super tight, but you end up with a horrible user experience because you end up with these like giant matrices of permissions that people need to understand, or, opaque error messages where it's like, you don't have permission to do this, go ask your admin. Like, what? I mean, it has a range. It has a range of implications.
Cool. So, in what made you want to tackle this kind of big, hairy problem domain, and what was sort of the backstory? Like, how did you get into this? How did you meet your co-founder, and what got you kind of started into diving into this problem?
Yeah, so I met my co-founder Graham when I was pretty early in that process with Cornell Tech of understanding what problems were out there, and I was having that thought process where it's like, there are currently, if you're a developer implementing security, you almost need to have a PhD in security because the tooling's just not there. Like a bunch of you need to understand which like algorithms you should be using. All these details are exposed that shouldn't be. Like it's kind of there's like a tooling problem here. And I met Graham, who at the time was at MongoDB, and so he had that perspective from basically like the database world. Like, what if we didn't want every developer to be a database admin in order to like, deploy an app, and like how can we make that stuff easier? So we kind of instantly had this, really fun conversation around just like the problem to be solved there, right? Just making security more accessible for developers. That's kind of how it all started. And that's sort of been our like, North Star for the whole time. And, so we originally, we didn't start out with authorization. We originally looked around a little bit in secrets management. We were building sort of an infrastructure security product that did more cryptographic based things around like securing connections between services with things like encryption, authentication built in.
Got it.
We were really going out there, like speaking to as many developers as possible. and security teams. And we were hearing a lot of like positive things from security teams, but not from developers, who it was like, for some of the infrastructure security stuff, would rather just not be dealing with it at all. But we did hear from those teams. They'd say, yeah, we don't really handle the, like TLS between services, things like that. But we did just spend like 9 to 12 months building this role system, or we just spent like, all this time building an authorization service. Like, does your product handle that? And at the time we were like, nah, we're doing the infrastructure thing. And, it honestly, it didn't feel great. We were building this product that, it wasn't really resonating with developers. It was more resonating with security, and it was getting away from that like original goal. So, almost 2 years ago, we decided to pivot towards the application authorization side of things, go back to those developers we've spoken to and like understand that use case a bit more. And that's kind of, that just felt like a huge load had been lifted off of us. It was like kind of getting back to our base.
Yeah, that's awesome. What sort of pain points came up frequently when you spoke to developers and they shared, their access control experiences?
Yeah, I mean, it was really interesting because it wasn't. We had such a range. As I said, there's some people who just said, we just spent 9-12 months building this system. Like, where were you 2 years ago? We could just skipped all that work, and that's kind of what you love to hear as a founder.
Yeah.
On the other hand, we did hear a lot of people who just were like, I could never even conceive of authorization as like a core part of my business logic. Like, I can't give that to you. I can't move that to something else. That doesn't make sense to me. Or it's, how do you solve this problem where, how do you solve this problem when we need to like fetch all of this was a particularly insightful company, who brought this one up. It was like, we have this problem where we need to like fill the data coming back from the database and, only return the ones that an authorized user can see. Like, how could your product possibly solve that? Because we had to do all this work.
Yeah. Because it's from their perspective, it's like, I wrote all this code and it's really probably indistinguishable in the code base from like the regular, application or the quote unquote like regular logic, right? Like, it's probably some conditional that checks, the user ID in the code. And how do you like rip that off into
exactly
a separate?
I mean, probably, it's probably something like every other company would do. It's, when you start fetching records from the database, you filter them by like the user's, organization ID or something. It's like, it's kind of authorization logic. If you go multi-tenant, then, how do you do that still? So that was some of the, I think, what we were really hearing then, which we didn't kind of know at the time, was like, I think that's a lot of why, it's been hard to solve this problem in the past. Like, how do you balance those like kind of two tensions, or it's like, there's lots of work that people often do, but they often reinvent it, but it's like deeply embedded in the application. Like, how can you solve that? Yeah.
It's also scary, though, to have that deeply embedded in the application, because the application code changes often frequently. And, what's to say that, some developer who's trying to like ship this other thing quickly inadvertently, removes that conditional that is, the hinge upon which the entire like enforcement of the permissions model relies.
Yeah, I mean, that's like a really interesting one, because at the same time, if you try and pull it out of the application entirely, then you might end up having something that is like fundamentally changing your app like logic that is sort of now being like decoupled from it. So like, you can potentially deploy changes that just breaks your entire app because it's there's a really tough balance to get there. It's in some ways I think I'd rather have like changes to my authorization logic go through my like regular CI process, because it is just part of my app, and I want it to be tested in that way.
So what is your kind of like principled way of thinking about authorization? Like, you've written a lot of guides on how to think about oddsy. Oso has published a lot of useful guides, and you've kind of broken it down into different parts, enforcement, decision, and things like that. is there like a 10-minute primer that you can give me that kind of lays out the core things I should be thinking about with respect to oddsy as an application developer?
Yeah, absolutely. So let's talk this through. Let's do this in like using an example, and I'll like walk through like a typical request to my web app and like what's going to happen. So we use GitHub a lot as an example. It's got some very rich data structures and everyone's sort of familiar with them. Think about the process that, GitHub might go through when, you go and click, merge on a pull request or something, right? So the, request gets fired off to go merge that pull request. It probably, maybe goes through various different API layers and eventually, maybe reaches like and there's, so you have a choice, like, do I want to try and do authorization like over this request object, right? Like this HTTP request comes in, I could probably introspect it and see, oh yeah, this is a merge pull request to, such and such a, the Acme Anvil repository. And, I can see it's this user from the token. You could try and make an authorization decision like right there over that request. But probably what you're going to end up doing is like fetching authorization information from a database, like the application data. We'll kind of get back to that one in a sec. But and so deciding where do you do that little piece of logic, saying like should this request go through or not? That's enforcement.
Yep.
And you can choose like different layers inside your app of where to do enforcement. So what I was describing was like maybe. At the front door, the entry point, at like the API level, I could maybe inspect that request and say, is this request authorized or not? More typically, what you see is that logic is handled like more inside like the application code, like in the web controller, that type of thing. So inside your whatever is your like Rails app or something, you've got your controller method that's to merge a PR. That's going to check that logic, right? It's going to say, okay, when I've got this request to merge this PR, I fetch the current user probably in some middleware. And now I want to do that enforcement of like, should I let this go through or not? And so, basically at that point, you sort of switch over to like the authorization decision. So basically that's the point, right? You decide, should this user be allowed to perform this action on that resource? Right? Should this user be allowed to merge a pull request in this repository? So we call that like the decision. And there's basically within the decision, there is sort of two sub pieces that are really important. One is like the abstract logic, and the abstract logic means the sort of the structures, the models you have in place to make those kinds of decisions. And so more concretely, we're talking about things like roles. Right, so a lot of logic inside GitHub is modeled around not what a user can do, but what a user with a role can do. So it's like, oh, I see, Sam, as a member of the Acme organization and the Anvil repository belongs to that one, it has certain privileges, and so that's like that's right there is sort of the abstract logic piece that says members can merge PRs. And like deeply coupled with that is the authorization data. So if the logic is like the abstract piece, the data is the concrete piece that filtered in. So it's like the bit that says, yes, Sam is a member of this org. It says this repository belongs to that org. It says this pull request is inside that repository. Like all of those are pieces of data, and they typically live, in your application, in your database. And you basically need the two, right? You have the kind of the code, the core logic, plus the data, you put them together and you can make a decision. You can say like, yes, Sam is allowed to merge this PR. And so that's your sort of like typical like authorization flow as it kind of goes through those pieces, right? The request gets the enforcement needs to sort of ask that question, get a decision back.
Can I ask you a question about the enforcement aspect of it? I remember having this debate with another engineer on our team once upon a time about where the proper place was to enforce the auth policy. So the two options were API layer, as you mentioned in your example. The argument being, the API boundary is sort of the outer boundary of the application. And so this is the point at which you should be checking for permissions, because anything that's leaving this boundary is going to, some consumer on the outside. And this is the point where we need to guarantee permissions. The other side of the argument was, no, it should be actually as close to the underlying data as possible, because the data, the data in the actual database, all that is sensitive, and you don't want to have this thing where you combine bits and pieces of data at the API layer or some in some middle layer, and then you miss the check at the data layer, and then the API author doesn't realize that there's actually private sensitive data kind of jammed in somewhere in this API response, because it's gone through so many transformations on its way to the end user. And then, the counter argument to that was well, what about something like search, which is, directly relevant to Sourcegraph, where it's if you check the union of all possible matches before you actually do the search, then it's intractable, right? Because you're not going to check every single possible line of code for its permissions. You're going to run the search first, look at the results that you get, and then filter afterwards. Much more efficient to do that. So there's a whole conversation around proper place to enforce the authorization model. Now, do you have a kind of principled way to think about this? Is there a mental framework that you've kind of just
yeah.
I know it's an impossible question to answer, but
we've tried.
What would be your approach?
We've tried. I mean, welcome to why authorization is hard/fun. We wrote an entire 5,000 word guide on this. There are, I think you mentioned sort of two places you can do enforcement. I think there's really 4.
Wow. Okay.
One of them's kind of a trick question. So one place you can do enforcement is in the user interface itself. But I mean, the caveat there is you can't actually that can't be the only place you do it, because someone can easily bypass your front end code and just make a request themselves. But so it might be an additional one you want to do. And that's the classic, don't display the delete button if the user can't delete the thing. That's kind of inform enforcement.
Yeah.
So that one's nice. It's kind of separate, but it's nice. So, and then you have, the API layer, we call that the request layer. You have inside the application code, inside a controller method, inside the core business logic. Yeah. And then you have sort of at the data access layer. And yeah, it has the trade-offs that you mentioned, the doing something as an API middleware can sound so good, because you can just say I'm just going to do it once, it's going to apply to every request, and I'm never going to forget it. But what ends up happening is, to be able to make that authorization decision, you need to end up basically duplicating a bunch of what the application logic itself does to understand, to kind of turn that request into something meaningful, so the right thing to authorize. And so that ends up being pretty painful and duplicative, and it hits on this topic that comes up a lot, which is, the thing you're really striving for with authorization logic is to have this clean separation between the application code and the authorization logic. And it's very easy for those lines to blur in either direction. And so this would be an example of actually your app code spilling into your authorization logic, where you're now re-implementing, your request routing mechanism that can pass HTTP requests into business logic, and what those things mean and what those things need to do, and so on. So typically we just say, request layer, it's, you should only use it for very coarse checks that you really can do at that layer. Which can be things is the user logged in? Maybe the user is, maybe it's a request coming with an API key, and the API key has a list of scopes of what it can do. Like when you get into like that granularity, you can just sort of do this thing where it's like, this API key only has the read scope, but it's trying to do a post request. So I'm going to reject it. And it's like that kind of checks out. But yeah, really you want to do your, I think the best place is, closest to the data is kind of one way of putting it. We sort of say it's where you can ask like the most specific version of the question, like where you have like all the relevant context of what the user's trying to do and the action you're actually trying to like authorize or enforce. Because authorization is messy. I had a really interesting use case the other day where it was like, I'll keep it pretty generic, but it was, an app that needed to access a piece of like personal information, and it was allowed to on one page, but not on a different page because, despite thinking, you might think that there's like a clean abstract authorization model, but really everything has business requirements. And this one was like, if they're in this page flow, then yes, they can see that piece of personal information, but in this page flow, they can't. And they're like, I know it's terrible, but that's just how the app works. That's the business requirement. So, they just, that context was necessary. And that's a pretty extreme example, but you get similar versions of that. So you want the authorization in kind of like the most specific place you can. One thing you can often do is like apply broad generic checks at the data access layer. Like make sure the user is allowed to read this piece of data or read any piece of data that comes back from the database, the user should be allowed to read it. Like that can be a really good like filter that you apply to everything. And it might be the case that afterwards you need to go and check something else. Like, all right, but in this case, they're actually trying to, update this field or something, and then fine, go and check the user can update that field. But it actually makes a really nice balance between having that like authorizations applied to everything by default and, without you need to get like too clever around how you tell the database layer, like what things to authorize. That's kind of where it gets tricky.
Yeah, makes sense. Do you see people combining enforcement at different layers? Just as almost like a double check. Like, we're checking this at the data layer, but might as well apply this other check at the API layer, absolutely. Just in case something.
Depends in depth. It's all about that. I mean, that's great. Like, as long as the system you have is convenient enough for doing that, and you're not gonna end up hating yourself for doing it. Like if the tooling is good enough, then like absolutely, like why not? Because what it does mean is, you do miss a authorization enforcement check, and your tests haven't caught it or something, but maybe you still have that request level check. So at least the user needs to be logged in or something. It's not just completely open to anybody. Defense in depth can, reduce that blast radius. Yeah.
So how does Oso help with enforcement and decision, these two big categories? Is there one or the other that it's kind of like more interesting for? Would you say it's both, or like what would be the first cool thing to show off?
They are both so cool. I think I'm not sure which is best. I'll leave it to you and the viewers/listeners to decide which is coolest. But so on the enforcement side, we have a set of APIs that basically help you do authorization and enforcement across like any of these layers. So if you want to do you want to apply your authorization logic over your database queries, or if you want to like expose stuff to the UI, like we have APIs to help with all of that.
Cool.
So that's fun. And we can see that in a demo, like how that turns out. And I think on the logic side is really interesting because we basically built a language to help with expressing authorization logic in a way which, we hope removes a lot of the difficulties and kind of allows you to focus on the core, like how do I want my app to behave? Like how is my app structured? Like how should it work as instead of kind of the tedious making sure I got my logic in all the right places and things like that. And so that stuff is pretty novel and new as well. And like the two, I guess the nice thing is the two go hand in hand. So we have all these different places where you can do enforcement, and they all just use that one single piece of logic, which is kind of nice.
When you're explaining Oso or showing off Oso to new users, do you typically start with the decision side or the enforcement side?
That's a good question. I mean, it depends on what problem people are trying to solve, honestly. And I will say a lot of people, when you put it that way, like a lot of what we do hear from people is like, I'm not sure how to even think about my authorization structure right now. Like, I'm not sure what model I should or should be using. Like, can you tell me?
Yeah. Why don't we start with the decision side then? Because I think that's where like the auth model is actually defined, and then maybe that motivates like, well, where is this enforced, or how do I actually enforce this in my app?
I mean, the enforcement is kind of the bit that makes it concrete. Like, and now here's how it's actually going to look in your app. It makes it real.
Yeah.
The logic piece is solving that like hard modeling challenge, and the enforcement makes it real.
Cool. So does this play into, like, you have kind of like a mini demo ready, right?
Yes.
Okay, cool. And then for those listening to this, there's video on YouTube, but for those who prefer the audio only experience, I will do my best to narrate what is happening on screen.
One place we could also start is, it can often be fun actually just to hear from you, like what's an application model you'd be interested in, like thinking through, and we could kind of like, we could talk through a use case live, and then I can go and show the sort of more complete version of the demo. How about that?
Yeah, that sounds good. Right. Can we use like Sourcegraph as the motivator?
Right, yeah. So
cool. Yeah. So do you just want me to like describe, I guess like I'll caveat this by saying my understanding of the oddsy model, because like there's people closer to that code than I am right now.
Yeah, we can just talk in, the general things. Like, okay, so like a really nice starting point, right? It's like, what's like the core resource that you're protecting, right? Like what's like a really good example of a typical representative piece of data that you're trying to protect in Sourcegraph?
For us, it's all about the code. So which code are you allowed to see? Private code. And that's typically permissioned by repository. So like, some people are allowed to see a particular repository, some people aren't. Some repositories are like public, some are private, some are open to anyone inside the company, but they're not like open to completely unauthenticated users. You have to be a member of the company. There's a notion of teams and organizations too. So like a team can be granted access to the code. And some of this, for us, it gets a little bit complex because some of this we try to sync over from code host permissions models. But some of our customers don't use, they either don't use like one of the standard code hosts, or they do, but they have like their own auth permissions malarkey in the mix, defined in like LDAP something or other.
So this could get a little. This is going to be very overlapping because the demo I have is also a GitHub clone, so we're going to have the same. We're going to have like identical concepts in a second, but let's run with this one for a second. I think this will work. So, okay, so right now I'm inside whatever. I'm inside my editor. I'm writing. You can see I'm writing in the bottom right. It says Polar. So Polar is the policy language that we developed at Oso. It's a logic-based programming language. That's kind of a fun separate topic that most people don't really need to.
It's like Prolog.
Yeah, it's heavily based on Prolog, but with features that we built in particularly to be amenable to authorization.
Cool. Awesome.
And yeah, so like the kind of the starting point. With Oso, writing policies is kind of describing your resources. And so you just mentioned repositories. And so what I'll start out with is what we call a resource block for a repository. And basically these blocks, they're just helping us define like the kind of the shape of my authorization logic. And a lot of it is very resource orientated. And so
cool. So you just typed in resource space capital repository, then open
curly
brackets.
braces. Yeah, exactly.
Yeah, open curly braces. Yep.
And so like within this resource block, basically what Oso wants me to do is define you sort of declare the different things that can happen on a repository or that exist on a repository. So I'm going to add like a few.
This is like read, write.
Yeah, exactly. So I'm going to write like the list of permissions that will exist on the repository. So whatever we'll say, like read and write.
These are all like actions that can be performed on this resource.
These are all things that we'd want to grant, deny access to. Can someone read a repository? Can they write a repository, something like that? So that's kind of like one thing. Typically, people will also express roles if you're doing role-based access control. We can leave that one blank for now. We'll come back to that. But if we had roles, we'd.
What about something like like an admin level access where I can grant other people read or write permissions? Is that something that you would put in permissions, or is that so you just added admin to roles?
Yeah.
But like the ability to grant read write, is that like another permission, or is that going to be described elsewhere in the model?
Yeah. So, okay. So you're touching onto a kind of interesting philosophical or modeling question here. So generally, I would say the best practice would be to try not to like mix and match authorization models here too much. So if you want to go with roles, which I think a lot of people should, very, very clean approach, stick with roles. So rather than saying like an admin can grant someone like read or write permissions, I might say admin is allowed to assign someone a role. And we'll like stick with roles for who can do what.
Got it.
Now, I guess I might otherwise have a. I'm not sure I'd construe it as an admin, but let's say instead that we had maybe like an ownership concept, like I know, like a document management system. You're the owner of a document, and you can just grant people direct access to something. You can just grant them direct read or write access. You might do that through a permission. It gets blurred.
I see.
So let's go with like admin and member. And indeed, we might to complete what we're talking about. Let's add to permissions that there is also a permission to assign role.
Okay. So we got 3 permissions: read, write, assign role, and then 2 roles: admin and member.
Exactly.
All within the repository.
All within
resource.
our repository resource. Now we might come back and change this later. It's kind of this is the point of of the policy language here is that we'll make that nice and easy. So the third thing that you declare inside this resource block would be the relations, and this is a like incredibly powerful concept to have inside your authorization model. So again, it's another thing we put inside the block, but instead of being a list, this one's going to look more like a dictionary. And basically, what the relations are, you're going to have like the key of this dictionary is going to be the sort of relation name, and the value will be the another resource. So we've only got repository right now as a resource, but you mentioned organizations earlier. So I might, for example, say that a repository has a parent relation, and the parent is of type organization. And so basically, what I'm doing here is I'm declaring the structure of my like app data as well. So I'm saying repositories have a parent organization, and by declaring that, I'm going to be able to use it in my logic later. Okay, cool. So that's okay. So I've like declared the main things. Now I can start doing inside this resource block is I can start like assigning permissions to roles and things. So we've already said earlier that admins can assign roles. So the way I'd write that, I just write it's still inside that same block. I can just write assign role if admin. And basically this syntax here is kind of like shorthand syntax for polar rules and polar logic. And basically says user has a permission to assign a role for a repository if the user has the admin role for that repository. And we sort of know this because that was the information we declared earlier. But just like that, I've now granted permission to an admin, and we can kind of go through and do similar, right? We can say, maybe read if you're a member. That sounds about right. We could write.
So you're just listing out these conditionals, which like my mental model is those just get like executed in order, to check if like, I guess later we'll inject like a user into this with a particular role. And if any of these returns true, we return true. Otherwise, if it falls to the end of this without triggering any of these conditions, it's
exactly.
No. It's
so
false.
that's a great point as well. So, the model here by default, everything is just deny. So when I just start out with Oso, it's going to reject everything.
Yeah. Cool.
And that's kind of like, I'd say it's considered a best practice inside for authorization permissions is you always want to be additive. As soon as you start going into negatives, you can do it, but it'll make your life harder, and you should sort of reserve that until you really, to the last possible moment.
Yeah.
But yes. Yeah. So you're right. So it's going to go through, it's going to check each of these kind of like little rules. Cool. And, if none of them are true, then, the user can't do a thing. Cool. Okay. So that's my resource block. And basically the way this is going to like actually evaluate through, so we sort of by convention, we have this like entry point to a policy, which is an allow rule. And basically, this takes the format of this is the same structure of our like enforcement thing. So you say, a user is allowed to perform an action on a resource if, and then some conditions are true. So what we're looking at now, this is like the full expanded version of like polar rule syntax, where we're getting into the logic programming. Sort of looks a little bit like a method, except it's kind of this like conditional syntax thing.
Yeah, it's interesting.
And basically what we need to check is that the user is allowed to do a thing if the user has permission to do a thing. And the permissions are defined by that resource block we wrote. So when I was talking it through, I said, a user has permission to assign a role if the user, has the admin role on the repository. So now I've kind of like hooked everything up. That's my like authorization model.
Where is has permission defined though? It looks like you're invoking you're not. Are you referencing something called has permission there?
So when I said these,
like a built-in.
So that's basically referencing these the rules that we expressed inside this resource block. So the read if admin is actually kind of is expanding to a like the full version of that is has permission. It takes a user and it says they can read a repository if has role, so on and so on. So this is like shorthand syntax for that. So that's what's been referenced. We debated removing this and just making this like the default, but kind of like the explicitness.
Wait, so sorry. What is shorthand for what? Is it the list of condition? The list of conditionals is shorthand for the like. Otherwise, you would have defined has permission inside the resource block.
Yeah. So this would be the full. This would be the full version of it. So you have to write has permission user to read a repository if has role user member repository.
But that's would you put that inside the resource block?
No, the resource block here is just for writing. This is kind of like syntactic sugar in here to. Make it easier to write this like complex logic.
Got it. That makes a bunch of sense.
So this is actually kind of a nice segue because some of the things you mentioned earlier was some repositories are public or private, so on and so on. Kind of the nice thing about this system of this kind of rule logic is it's very easy to bring in, to extend it, customize it, add like your own piece of logic. So. For example, I might say that, a user can read a repository if the repository is public. So instead of has role, I'm just going to write repository dot and then public. And in this case, I can actually edit the user. So
now that implies the existence of an attribute called public on repository.
That implies exactly. You got it.
Do you define that in the resource block then in Polar, or is that just something? Is it like JavaScript where you just reference things that may or may not exist? So
this is
as attributes on.
So now we're kind of getting into the application data piece of things, right? So remember we said decisions is logic and data. I think the piece you picked up on is, we've been writing logic so far. Where's the data coming from? And basically.
Yeah.
with Oso and like the way we built the library is that you would be expressing your logic over your application data. So repository.public, that will be coming from your application. Repository will be the concrete instance of an object or coming in from your application. So we're reading it off of that. So when we're checking that permission, we will read it off of the repository. Yeah.
And I assume that if any of these are like undefined, then it will just fail.
Exactly.
Like it won't.
You'll get an error. So.
Like it won't do the stupid JavaScript thing where it treats undefined as falsy, and then depending on how you defined your logic here, if your application accidentally leaves that field off. Like I assume that all that works in the way you expect it to.
I mean that's a really interesting question. This is one of the things we've had to deal with is because the logic here is separate from like the host language, JavaScript, Go, Python, wherever it is. We need to decide what's the right way to do it in each language. So we actually decided to be stricter here in JavaScript land than JavaScript itself, where we actually just recently added the check that if the field doesn't exist on the object, we will throw an error, even though JavaScript will happily return undefined.
Thank you. I think that was the right. It sounds like the right call.
Yeah.
Err on the side of being a little conservative.
Yeah. We've been discussing this one a lot. It's a really fascinating question, like that, to get that boundary right. I think there's more we can do here to be go a little bit more on the strict side actually, and sort of and then there's interesting balance between ease of use here and not requiring you to do a bunch of work, but also get that sort of correctness and strictness. But we got some plans on how we can have that even clearer and sort of have that interface like a bit stricter as well.
Cool.
All right, so there we go. We have your authorization model. What do you think?
That was easy.
I'm glad you think so.
This is like 20 lines of code.
Not bad, is it? Let's.
Not bad at all.
I think what we've done so far, though, it's pretty clean, but it's not. I wouldn't say this is something that is really. It's not doing that much yet, right? We're just based on the role you have in a repository.
True. It's a very simple
assign role.
Yeah.
I think where this can get really powerful is if we come back to this relations thing. So I kind of just like hand waved around it, parent organization. We'll come back to it. So let's do it now. So I'm gonna add another resource, my organization resource, much like I did with the repository, same syntax. And I mean, let's say, and maybe this is, we're mid design. We're talking through how we want to make our logic work, and you helpfully pointed out, that actually we don't want to have admin member roles on every repository. Actually, that's an organization level concern. And so what I'm going to do, I'm actually going to move those roles up into my organization block instead. Cool. So I'm going to move them out of repository into organization. So now roles define the organization instead. But down here in my repository resource block, I said, read if member, which meant you can read a repository if you're a member of the repository. But that's not a thing anymore. Now it's a member on the organization. And so we have this additional piece in the shorthand syntax. There's really only two things you can write, this read if member and this second one, which is you can say read if member on parent. And the parent there, again, referencing this relation to an organization. And so what I've now written here is instead of just saying read if you're a member of the repository, it says read if you're a member on the parent organization.
Got it. Can you compose? So like, my brain immediately goes to like, okay, a relation is like an edge from one node to the other, repository to organization. Now, what if you had like some other thing called like super organization and that had its own roles? Could you do like read if member on parent on, guess parent?
We decided to not allow that. And there's no technical reason. It's more of a, not handing out too many foot
prescribing
guns.
best practices.
So,
Yeah, fair enough.
But we'll see a model of that. I mean, we're getting very close to GitHub's organized model here. But so suppose I've got a different child. I've got like a another issue resource, and we're going to have same as before, like the parent of an issue is a repository.
Yes.
Then indeed, what I might want to say is something like you can read a repository if, let's say, I'm going to have to define my permissions down here as well. You can read a repository if you have the read permission on the parent. Mm-hmm. Right, and so and now we are sort of composing, because you can read the issue if you can read the repository. You can read the repository if you're a member of the organization. So
cool.
We are kind of doing
that
those arbitrary depth things, but I think keeping them like one hop at a time. So far, we feel is like a slightly better balance of,
Yeah. So like what you're essentially prescribing is like the authorization logic for a given resource should be a little bit agnostic of roles beyond like one level.
Pretty much. Like I couldn't come up with a use case where for example, so we're in the GitHub model now, right? I couldn't think of a use case where you wanted to say what someone could do to a specific issue, where you wanted to like skip what they could do on the repository and go straight to the organization. It just didn't. It didn't quite make sense to me. Like even if you have a super admin role on the organization to do anything, then that means they're a super admin on a repository. Just do that.
If you think about like how your human brain thinks about it, it's like that issue belongs to that repository, and if I'm able to do something on that repository, I should be able to do like the quote unquote similar action or the same action on the issue. You're not thinking of like the issue belonging to the organization because it's kind of fully contained within the repository.
And it reduces the number of like paths you need to try and figure out, trace through in your head, like
yeah.
Cool. So that's I think that's like a pretty reasonable summary of like all the things that are going on here.
I mean, this is a non-trivial auth model now. You got repositories and issues in organizations, and
like a little hierarchy of resources.
You wrote it in very little code. It's like 26 lines of code.
What I love about this is my like favorite piece of this is, we just kind of had a conversation, right? And that's how I want to think of it. It's like, I want people, people have like a conversation with Oso where it's like, I'm just going to tell you what I have in my hands. I got these relations, I got these resources. I'm going to tell you what I have and like lay that out. And then I could just like start talking through like, all right, what do we want to work out? Okay. Maybe we weren't happy with read if read on parent. Like that doesn't feel granular enough. I don't know. There's too many things. I don't want to group them together. So now I'm going to bring in repository roles. I'm going to say, I'm going to put admin on a repository. And I'm going to say that, you're a member of a repository if you're a member of the org. Let's just like imply things. And, then, like you can just like shape it however you want. And like all of these changes are you just focus on the logic. We haven't really spoken about like the way this integrates with the application data, but, we can look at a live demo and like play around with that and see it changing.
Yeah, I would love to see how enforcement looks, because I'm liking this so far. I like the cleanness of this and how it's separate from, because like, I'm trying to think like how would I introduce the authorization logic in Sourcegraph to like a new engineer onboarding right now. And it'd probably be a lot messier than this. Probably be like, okay, this is the function that gets invoked in every like low level data handler. That's kind of like enforcement, but it also involves a bit of the policy checking, the decision, because in that function there's a bunch of conditional statements, if statements, that reference functions that check various parts of the auth model.
So let's check it out. So hopefully we've just been doing all this in the domain model of GitHub. So there's going to be kind of zero context switching here to show a demo app. So basically we have this demo app that we called Git Club. It's GitHub clone. It's available on GitHub. So anyone, that gets confusing. If you go to gitclub.dev, gitclub.dev will take you to the repo that has this code in it. This is all public stuff. So we have this app that basically shows you what this looks like, kind of in a real one. So We have different backends to show in different languages. I'm going to stick with like the Express one. I want repo controller. So I can probably zoom that out a little bit. Okay. Let's look at this. I'm going to just like move everything else off the screen for focus. All right. So let's look at this controller method. So
this TypeScript code.
Exactly. Yeah, this is our Express TypeORM TypeScript example app.
Okay, and you're taking in what looks to be like an HTTP request or some representation.
Yes, this is like an Express request object. This is our controller method to fetch a single repository. So,
got it.
We're going to go and we'll fetch that repository from the database using TypeORM, and basically just call this oso.authorize method that takes in the user from the request object. Authorize if the user can read the repository. And that's it. That's like the one method we need. If this fails, Oso is going to return, throw an error, which can be handled by error handlers, things like that. That's the enforcement. That's it. Same API everywhere, basically. So if I scroll down to my like,
wait, scroll back up. I have a couple of questions. Okay, so so request.oso.authorize. Okay, and then you're just passing it the user, and then you're passing the
string
permission
read,
that you want to. Yeah.
So the action the user's trying to do.
Yeah, okay, and then the repo.
And the repository itself.
Okay, that's
straight
brilliant.
in.
And I assume it like throws an error if it's a no.
So there's a few best practices we've encoded in here as well. So there's this kind of,
because you want to avoid conditional errors. I'm guessing like if it returned a boolean, then like you check the conditional.
It's that for one hand is just a bit tedious to write if authorize everywhere.
Yes.
There's another subtlety we cover here, which is often, if a user is not allowed to read something, you actually often want to return a 404 and not found error to them, because sometimes just revealing the existence of a thing is bad, right? Like I could go to the, oso org / and top secret project, and maybe that, project code name is like, I don't know, Sourcegraph competitor or something. OSOHQ / Sourcegraph competitor. I don't want you to be able to like try and hit that URL and just tell you like you can't read this. I want it to pretend it doesn't exist. It's private. So we baked this into the interface as well, where if you
cool.
Because this can be a subtlety that's really easy to forget, right? Like let's go and look at our like delete endpoint to delete a repository. So here we're going to check, can the user delete the repo? Exactly the same method as before. So fine, like, maybe you try and delete oso / Sourcegraph competitor and it'll just tell you like denied, you can't do that. So at least I didn't let you delete it.
Yeah.
But in telling you can't do it, it tells you that it might exist. So actually what you'd rather do here is if you're not even allowed to read this, I should just 404. I should just like hide it from you entirely. So this is what authorize will do. It'll first check, are you allowed to read the repo? If you can't, it's going to raise a 404 error. If you can, so you actually, you are a member of OSOHQ, but maybe you don't have the right permissions, you're not an admin, you'll get the, forbidden.
Yep.
So it's,
Now, there's a question here. I wouldn't expect you to do this because this may be like overly paranoid, but like one of the considerations here is if you don't want to leak the existence of certain things, like timing, can leak that information too, right? Like if it's an auth check that fails, then may return very quickly. But then if it actually doesn't exist, it goes through to the back end, and maybe there's more work that needs to be done there, so the request latency is higher. Do you have any facility for like trying to mask that difference in latency as well, or is that just
yes. In short, yes.
You do.
Sort
oh
of.
Wow. That is surprising.
So not through the approach that I've shown here, but so if I go up to, we'll come back to that one in like.
You don't have to show this off. I mean, like just the fact that it exists
very shortly, because I want to show you. We'll take a tiny detour through a different enforcement interface. So along with fetching, deleting a single repository, we have our like index endpoint, right? So get me all of the repositories. And in this case, this, for context, this is like a subpath on an organization. So, you can, so we're doing like a little bit of extra logic here, but basically, a user wants to, what are all the users there? On an organization page, list all the repositories. Now that list of repositories, like in some cases, it might just be if you can see the org page, then you can see all the repositories, but it might be that the index page itself is public, but specific repositories are not public. And so we have this additional enforcement interface here, authorized query, which is basically going to, you can see here, instead of taking in a concrete repository, it takes in this is like the class name, basically, the model. And it outputs a repository filter. So this is something I can append to my data access, my database query to filter down repositories by only those I can see. And it's going to take all of that lovely authorization logic we wrote earlier and basically, compile it down into, well, in this case, type ORM filter statements.
Interesting. Okay, so you get the org, and then you authorize and list repos just as like a pre-check. And then you invoke this authorized query method, which is on the Oso object, and that returns a filter object, which you can then
append
use
onto my actual query
to filter. But doesn't this make the enforcement a little bit maybe like less safe? Because like if I'm just scanning this code, I see this, await request authorized query line. But then what if the application developer forgets to use the filter that's returned by that?
So there's a chance. I mean,
I guess you can only do so much.
They could also make the terrible decision of not using Oso in the first place, and they even it's a great question.
This is a question I ask sometimes. Like, do you have like any sort of like static check library too that just like checks that the code invokes Oso in the proper places, or because that is something that I've considered for Sourcegraph just out of like abundance of caution.
Yeah, there's more we want to do here. This isn't something we've exposed yet, but the sort of idea of one of the things we do want to add to the product is basically something that can check whether authorization took place in the inner request scope, so the inner request span. So you kind of know that at least somewhere like authorization was applied.
Oh, that'd be cool. Yeah.
We don't have that right now, but yeah, more to come.
Yeah, makes sense. Cool.
So this is really nice because the authorization logic, as we saw, can get quite complex. But the enforcement stays the same even over these like index endpoints. And so to come back to your other question, around like hiding whether the timing attack potential between seeing the resource and authorizing the resource. If you apply this kind of pattern everywhere, so if you use that like data access layer pattern everywhere, then anytime you fetch anything from the database, it's going to have that authorization applied. And so I mentioned this earlier, right? Like if you just applied read level permissions across everything, then the app literally can't differentiate if the thing exists in the database or not. Every time it fetches it, it's just pre-filtered by authorization.
Which is beautiful. It's like exactly what you want.
Which is it's kind of the same sort of thing you get from, like a lot of people talk about doing this fully in the database, like Postgres has like row level security and stuff like that. The challenge with that is you end up duplicating a lot of your like application logic in the database, but it's got a similar approach to that. All right, so let's see what this looks like in a real app. I feel like we've been staring at code long enough.
All right, let's do it.
So here's my beautiful React app, super modern and responsive. So yeah, you can see
gorgeous.
You can see up here I am. Let me log out first. I'll probably get some horrible errors from doing that.
So for those listening, it's a very bare bones, like a white screen, and
don't listen to him. It's
vanilla font.
beautifully designed.
I'm sure a lot of design.
GitHub, people on the stream, please don't try and poach our front end developers. No, we won't stick to just the basics. I don't want to be distracted by all the UI stuff. All right, so you can see I can log in as a user. So I logged in as john@beatles.com. If someone's paying attention, I didn't have to enter a password because that's out of scope of this demo.
Well, authn is not part of what we're concerned about here, right?
Now. Those two are nicely decoupled.
Yeah.
So I've got my little landing page here that's going to show me all the repositories I can see and all the issues I can see. And so I'm going to split my screen and have that up in one screen, and then start writing some authorization logic. Okay, so basically I have on the right side of my screen now the full version of the my GitHub example policy. It's going to look very similar to what we just saw before, except it's a bit more filled out with other bits and pieces. Okay, so the main thing I want to show here is we can start playing around with this, and we'll see the impact of this on our front end, the permissions I can see. So for example, let's just go ahead and write an allow anything rule. So I'm going to say any user can do. Is this going to work? Can do any action on any, let's say, on any resource. So I'm going to do a nice blanket allow here. I should have my Node app should be recompiling in the background, and my React app should be refreshing the web page, unless I messed up. Probably messed up here, didn't I? What if I get rid of that? What if I just say users can do anything? Oh, live demos.
Yeah.
I wonder whether something broke while I was doing other things and talking. Let's have a look. Oh, thank you. Oh, right, that makes sense. Okay. All right, I can't be quite so eager. Let's just say users can read anything.
Got it. Won't let you be that cavalier. It's there's no way that you ever want that. Allow any permission to anyone.
That sounds ludicrous. Seems like we're still getting. Oh, there we go. Okay, finally refreshed. Cool. So now I can see all the data I have in here, and it's not a ton. And I can see I've got this other repository. So I've got the Beatles Abbey Road repository and the Monsters Inc. paperwork repository. And this. The nice thing is here, right? I can change my authorization logic and start seeing what the impact is going to be on my app. So first I said that users can read anything. Let's say that users can delete anything as well. Let's see how we got on with that. And so basically
so you just added an allow all for delete, and we're waiting for the app to refresh. And I assume that grayed out delete button. Yep, there it goes. Yeah. It turned red.
And so this is this is kind of the end to end here, right, of authorization. It's I've got my authorization logic, my policy that's saying things like what a user can read and delete, and it's propagating all the way down to the front end to the point of listing all the repositories the user can see and what they can do within those.
I love how clean this is, because if this were just embedded in your application code, at least for me, every time I make a change to that code, I'm just staring at it, rereading it just to make sure, didn't inadvertently we have tests and all that, but just to make double sure. But here it's okay, it's obvious. It's all in this nice, encapsulated in this nice policy file.
And I can, and like we were talking about earlier, right? I've got my, user can read an issue if they're a read on the parent. That's let's just go ahead and get rid of that. No, I don't want that to be true any longer. No reading of issues. You're only gonna allow to do the thing if I give you explicit permission. I regret saying my refresh too slow, but there we go. Our issues disappeared because the user no longer can read it.
Wow, that's awesome.
Yeah, so that's kind of the end state, and it kind of closes the loop of what we're talking about, which is that the sort of my dream end state is that someone can really, they can basically build their app and they can put the enforcement in the right place, and then they get to just have that that fun of like deciding who can do what, like how should their app work, how are things tied together, and
So, question. This is all open source. Like everything you've shown so far, like anyone can just embed as like a dependency in their application. Is that right? Or is there? I guess my question is like, I feel like I should pay you some amount of money for this. What would I pay you for, and how do I do that?
So this is all open source. When we're a startup, we are ultimately here to build a successful company and a successful product. Don't get me wrong, like I love open source. I'm like a believer in it, in the the beauty of it and the amazingness of open source, but I wouldn't say that extends as far as me saying like I must pursue an open source company. It's like the only thing I'll do. The reason we ended up there is because, going back to those early conversations, like where people saying I don't see how I could put this like core business logic like outside of my app, and like the deeply entangled nature of it, that it needs to read that application data, so on and so on. That led to us being like deciding that we must leave authorization like inside the application. Like the library is the best place to do it. You have enforcement, like enforcement is in the app. Like there's nowhere else to do it. It's like you have that footprint. If you're going to do a library for authorization, and like some people are going to embed that, like I do believe the right thing for the developer is that's open source, that like you can see and control the thing that you're integrating into your app. And so that's kind of like what led us here, was like we just felt that's the right way to solve this part of the problem. And for us, in terms of like, it's like our focus right now really is just like making this library as widespread and as useful as possible. But ultimately the future for us is around like, well, how can we continue to solve this problem and more of the problem? And if the problems that we think are worth solving and the solutions we have that we think are the right way to solve them is a service, then that's kind of what we're planning on building and commercializing. But it's sort of,
makes sense.
For us, it's driven from the solving the right problems first, and then making sure there's a viable business model around that. Like it's,
Yeah, this is a whole can of worms discussion, because like it's interesting that the predominant model for realizing revenue off of software is to offer it as a service, which is, it seems like backward in a way, because like a lot of times the real value, I guess, comes from the actual code, the logic, and then running it as a service is almost like you're trying to manufacture a reason to charge for it, I guess. The predominant like wisdom right now is like cloud is the future, but I think cloud is the future precisely because like cloud offers a viable and sustainable business model for software. You just offer it as a service on the cloud. But for me as a programmer, I still can't shake this like, oh really? Like that's what we're charging for? Just like running the software, not actually like writing it and coming up with all the like algorithms and data structures and design.
In some ways we are like unlucky and lucky and unlucky that that's not the shape of the problem for us. Like, the approach we're taking and our rationale for what we're building is that it should live in the application. So for us to say like, we'll just manage that for you, like doesn't make any sense. That's a different product. We do believe though, there is like a lot of functionality that we could best offer through a service, basically, that the stuff that just wouldn't make sense for it to be like embedded in this library. And it's, the kinds of things we're thinking, they span from like a service that will just give you like roles, permissions, admin dashboards, like kind of API in a box that you just get to like add to your app and run with it. Through to security tooling, like, auditing, which just like comes up a ton, and would be something that developers, that a team would otherwise have to build themselves. On top of all of this, they would need to figure out how to manage and store all this data and, process that efficiently. And it's like, I think there's there's like a wide range of value that we can offer on top of this library. We're just kind of giving everyone that like foundation layer first, where it's like, let's figure out how to make your app piece work well. And, from there, it's like I guess we have like plenty of areas of things we want to address next.
That makes sense. You're building this resource. You're making it available to everyone as open source, but then you naturally are going to be the experts in that resource, and you'll be like the best equipped to build a service, software as a service business to complement the value that open resource provides.
And we're basically betting on the fact that I think a lot of people will kind of appreciate and respect the approach we took with the open source library, and that see that we sort of have developers' trust in kind of in our minds. So like that's the approach we're taking. We're not just building a service for the sake of it. We're just trying to figure out the right way to solve the problems.
Yeah, makes sense. So just to round out this whole conversation, if people are listening and they're curious about Oso, they want to give it a try, where should they go?
So you can't go wrong if you start with the website, osohq.com. You'll see a little widget built in there that gives you kind of a little demo version of what I just did, like in the website, that is actually driven from Oso itself in the browser. So that's kind of cool.
Nice.
And from there you can obviously go down different rabbit holes of the product, with the documentation itself, just go and learn how to start using this. And obviously, it's open source. You can pip install Oso, yarn add Oso, and get up and running. So you can go read the docs and get running yourself. Or we also have a community Slack. You can find the link for that through the website as well, where you can just come and talk to us directly and come chat about authorization, what you're trying to achieve, figure out if Oso is the right fit, ask us any questions, all that kind of stuff.
Awesome. Well, my guest today has been Sam Scott. Sam, thanks so much for being on the show.
Me.